We follow with the next session, the session 3. And here is Tomita, Akihiko Tomita, who is the chair. Thank you. Thank you, Tomita.
Okay. So, hello, everybody. Good morning or good evening or good afternoon. So this is Tomita in Japan, from my home, from my small room. This session includes pedagogical, psychological, and social aspects of astronomy education research. I'm not an expert of these areas, but I'm interested in and I would like to know a lot about these topics. Okay, so before starting the session, dear presentators, each presentation has only 10 minutes. Yes, 10 minutes. So I know that the 10 minutes is very short, but please include your presentation within 10 minutes. And after all of 4 presentations, we will have the 10 minutes Q&A session. So I will pick up some of the questions written in Q&A window. Dear all the participants, please write your questions in Q&A window. If Q&A window is not shown, write your questions in chat window. I will also look for some questions in chat window. Okay. So this session has 4 presentations. So originally in the timetable, so you can find 5 presentations, but the last one is canceled. So we have 4 presentations. Okay, so the first presenter is the Italo Testa from Italy. Okay, so Italo, are you there? Okay, so he is presenting about the astronomy identity. Okay, the stage is for you. So please go ahead.
Okay.
Mm-hmm.
I'm sharing the. Can you see my screen?
Yes, of course. Okay, clearly.
Go in presentation mode. Do you still see my screen? Yes.
Yes.
Okay. So in my talk, I will briefly describe our latest research on introducing a framework, a new framework. We call it astronomy identity. You can be useful to link interest, value, confidence, and conceptual knowledge in astronomy. This is mainly drawn from another framework that we have developed in physics. This is identity. So we try to translate many of the theoretical constructs into astronomy, into the astronomy field. So the dimension of our construct are mainly drawn from the physical identity. Now I cannot go in too much details, but I can answer in the questions later. We will focus here on 4 dimensions. There are the interest in astronomy, the utility value in astronomy, that means the perceived importance of astronomy for the future career and for the future of the students, confidence, which is a different construct from self-efficacy. Confidence is the self-assessment of the performance in a specific task, of course related to astronomy. And finally, the dimension also of conceptual knowledge that has been not so much focused on in the physical identity construct. For those of you who are not familiar with the physical identity construct, I can give you some more literature references after talk. So this is our hypothesized model. You see that the astronomy identity is the output variable, and with the other 4 dimensions that may affect the identity. We don't at the beginning of our research we didn't know which one of these effects are significant, and our research is going to answer to these questions. In particular, how do the interest, confidence, knowledge, and utility value contribute to the astronomy identity? Are there any significant relationships? How do the constructs and pathways in the astronomy model change with age? This is the focus of our second research question. From primary to lower secondary school. From primary, we mean fifth and sixth grade, more or less, and fifth grade is last year in Italy for primary education. Sixth grade is the first of the middle school. Eighth and ninth, the other grade that we involved in the other samples that we are included in our research. Eighth grade is the end of the middle school. After that, it begins the secondary school level with the ninth grade. So we try to have a longitudinal research in the sense that we involve not the same students, of course, because it's too much difficult, but different cohorts of students from different ages. Over the ages of fifth grade is about 9, 10 years old until 14, 15 years old. Okay. So these are our instruments that we used. We draw from a previous research by Bailey and Hall and Barrett with an instrument to investigate the interest of the students' interest in astronomy. And one, as usual in physics education research, one identity, one item on identity and one item on utility value. The conceptual test about knowledge in astronomy was concerned topics that were addressed in that school grades. It means seasons, eclipses, and moon phases. And that's the confidence scale. It means that for each of the questions in the conceptual knowledge scale, in the conceptual knowledge test, we asked how confident the students felt about their answer. So these are our results. I go very quickly to our results. Here in the orange box, you can see some technical details of the statistical of the structural equation modeling. If everyone is interested, I can give the details. However, for those of you who are familiar with this kind of analysis, all these indexes indicates that our structural model fits well our data. And in particular, we found a significant impact effect of the interest on astronomy identity, and also of the utility value on the astronomy identity, but also a mediated effect of utility value of interest on the identity. There were the other errors were not significant in our model. We found for our research question that age is an important correlate. It means that, as you can see here, the interest is very much affected by the age. This minus signs means that the interest decreases as the students go on from primary to middle school and secondary school. It also decreases the confidence in their knowledge. The interest, the other effects remains significant, but what the most important results is that age correlates with interest and also with confidence and utility value. So I will go quickly to our conclusions and implications. There will be much more to say, but what can we do with this framework? We can try to design and to route the design to the design of the activities, instructional activities, educational activities, based on how the interest changes over the years. So we cannot assume that interest is the same from primary to middle school and secondary level. And also, we cannot assume that the utility value and their confidence in their knowledge is the same. And since we cannot assume that, we cannot do the same type of activities of this different for this different age, but we have to measure before the activities what our sample is in the mediation model. What next from the research viewpoint? Well, we are currently revising the model, And we are currently including the upper secondary school students, which means 17, 18 years old. But in Italy, they do not do any more astronomy. They make something, they study something in physics, but gravitational forces and so on. We are now in the process also to include a national sample, while the sample was located in very school in our region, and we hope to make hopefully a call for international call after that we have validated some the items and so on. And also we are wondering if we can extend our results also to undergraduate studies in astrophysics. So I think that's I finished here. Thank you very much for your attention. This is my email, and you can send me questions and so on, whatever you want here. Thanks very much.
Thank you very much, Italo. So thank you, wrapping up your presentation within 10 minutes. Thank you very much. Okay, so we would like to move to the next presentation. The presenter is the Carla Perkins from United States, about the psychological and therapeutic benefits of astronomy as educational methodology. Okay, so Carla, the stage is for you. Are you there?
Yes, I
okay.
am.
Okay, so please go ahead.
Okay, I just need to find my presentation here and then to screen share.
Mm-hmm.
Okay. So can you see?
Yes, I can see.
Okay. Then
Yes, very beautiful presentation.
To here, it's not in the, there. Okay. Yes, it will be some artwork as well as presentation here. So, so today we're looking at the psychosocial and therapeutic benefits of astronomy as an educational methodology. Humanity is in need of a profound shift in perspective. Just a moment here, I need to shift this. There we go. I have to, going to close this. Okay, so I can see. All right, that's better. Excuse me, I'm going to start over again here. Humanity is in need of a profound shift in perspective and consciousness if we are to change our society adequately enough to transform the current challenges of continued sustainable coexistence as a species on our planet within the global ecosystem and with each other. Astronomy and astronomy education may provide a key and a portal. Astronomy education has the capacity for expanding the perspective beyond specific racial, cultural, and socio-religious paradigms while fostering respect and reverence for the diversity, totality, and integrity of all life. It facilitates comprehension of the radical interdependence of ecosystems across scales, from quantum through biological, sociocultural to cosmological. Astronomy and astrobiology education play roles in facilitating understanding of ecological diversity, appreciating with clarity the vital role of each aspect of life. So we see the Australian Aboriginal rainbow serpent at the bottom here, moving through the universe from the supernova to life on Earth in all its various dimensions. The psychobiological healing effects of focus on the vaster astronomical perspective may be significant. Research on brain and biophysiological effects of concentration on astronomical scales and phenomenology are yet to be undertaken. This deeply parallels and is similar to mindfulness practices, where extensive peer-review research has and is being pursued. This includes focus on the vastness of the sky and space as a domain of mindful pure awareness, the space-time substrate parallel to the substrate of consciousness. Literally, the mind and consciousness are expanding outward into participation in the vaster time-space scales beyond the earthly confines and normal stress factors. We're understanding that the actual fundamental substrate of cosmos is infinity. Particles are emergent properties of unbound probability waves that form the fabric of space-time. Without the concept of infinity, much of modern mathematics would not exist. It is found as a concept in the most ancient cultures. Regarding gravity from Einstein, we understand that without mass in space, there actually is no space-time structure. We continue to understand the significant role of the consciousness of the observer in determining the nature of perception, whether at the multi-frequency scales of the universe, at the scale of the photon, or of society. When we talk about spatial perception, it's usually understood as the space around us. However, space also includes part of our thinking. It is where we put all of our lived experiences together. The makeup of every particle of our bodies is, just as cosmos is, 99% space. Is it possible that space and consciousness are correlated? Consciousness studies is now a thriving new frontier of scientific research at most major universities around the world internationally. Cosmos and consciousness in dialogue. With this re-immersion in the astronomical scales and space itself, we experience a remedial dive into our own deeper origins. It is proposed that there is an ontological healing for our modern sense of alienation as we re-experience our integrity with the whole of cosmos and all life. Physicist Andre Linde at Stanford University said, "The universe and the observer exist as a pair. I cannot imagine a consistent theory of the universe that ignores consciousness." John Wheeler offered, "We are no longer satisfied with insights into particles or fields of force or geometry or even space and time. Today we demand of physics some understanding of existence itself." The frontier of research in cosmology, astronomy education, and consciousness are at the crest of this journey of inquiry. So what are we looking at? Infinities across scale, from the neural network of the brain to the neural network of the cosmos, and also the neural network of the heart. Yes, there is a whole neural structure within the heart. The group called HeartMath has published several scientific papers where they have discerned the whole fabric of the neural network of the heart, which communicates more to the brain than the brain actually does to the heart. Fascinating research. Neurons and the cosmic web. Does the human brain resemble the universe? In their paper published in Frontiers in Physics, Franco Vaza and Alberto Felitti investigated the similarities between two of the most challenging and complex systems in nature, the cosmic network of galaxies and the network of neuronal cells in the human brain. Surprising similarities emerged. We calculated the spectral density of both systems. This is a technique often employed in cosmology for studying spatial distribution of galaxies. Our analysis showed that the distribution of the fluctuations within the cerebrum neural network on a scale from 1 micrometer to 0.1 millimeters follows the same progression as the distribution of matter in the cosmic web, but of course on different scales. The two researchers also calculated other parameters characterizing both the neural network of the cosmic web, including the average number of connectomes in each node. The study was published in Frontiers in Physics called The Quantum Comparison Between the Neuronal Network of the Cosmic Web in February. So we're looking at the parallels of correlations of systems across scales, from the cosmological to the planetary to the human. Ancient Chinese science has much to say about this. Essentially here we're mapping the footprints of our own pathway onto the pulsations of our galaxy and the larger universe. It is a continuous flowing and interrelated map of existence. So where are we going? Toward a new universal culture.
Carla, 2 minutes left.
Okay, thank you. Yes, almost done. Composing the infinity of new culture at the convening of cosmos and the human mind, helping people see in new ways themselves, life, and reality, inspiring co-creativity with new scientific and universal culture, sensing of participation in an exciting new frontier and shared universal heritage. We are instilling a sense of reverence for all life and the dynamics which have given rise to it across scales. So I leave you with these questions. What do our understanding of astronomy and astrobiology imply about the nature and significance of each and every life expression on our planet, each unique bioorganism and ecosystem? What about the significance of each living species culture, the role of diversity and its integrity in the global life's response and resonance with cosmos? What is the potential of our own encounter in consciousness with cosmos? We are seekers following the heartbeat of cosmos, galloping into the great magnet in quest of truth. Thank you.
Okay, thank you very much, Carla. Thank you for excellent and inspiring presentation. Thank you very much.
Thank you.
Okay, so let's move to the next presentation by Corina, Lavinia, Toma from Romania, about the students' preconceptions in astrophysics. Corina, are you there?
Yes.
Okay,
You
so
see?
please go ahead. The stage is for you.
Yes. Do you see my presentation? Okay.
Yes.
Thank you very much. I begin with my excuse because I have a very great handicap because I follow after someone who knows English language very well. Also my presentation is not so to a scale of cosmos. We have to get down in a classroom. I'm only a teacher, not an astronomer, but I am a result of education in astronomy and astrophysics because I follow many times, 2 or 3 times, NASA courses of Rosa. And I know from only her, from all the panelists, and also you, Mr. Tomita, and from her words, and also Beatrice. And what I wanted to tell you about my experience in astronomy and astrophysics. In Romania, we have no astronomy in scholar, in education, in school, but I have some extracurriculum hours with astrophysics, especially because I am physics teacher. And what I want to, I cannot, okay, sorry. What it means a preconception at first, because to break them down, it means to know them. An idea, an opinion formed beforehand, or an idea formed before enough knowing about something. And we have to understand that, especially science teachers, that our students don't understand many times us. And we have to be very empathic and to realized that we were also students in many time ago, and to think about our thoughts in that time and to make all possible to make them to understand us. And I put these questions here, but it's very simple to answer to this question, because these preconceptions in astrophysics are not made to little ones or to big ones, also to us, to adults. We have many preconceptions, and is very, also in astrophysics, and it's very difficult to change that. And we spend too much effort to build other conception to a weak basis. And because of this, our duty is to spend more time to carefully remove this preconception. And now I want to show you only some of many preconceptions of my students, especially. How does the light propagate? I can ask also students from the last classes, and the answer usually rectilinearly is a propagation. It's made rectilinearly. Why? Because we tell them from the beginning that in geometrical optics is the first step in this issue, that the light is propagated directly. Also, when they learn about interference and about waves in optics, they know also that the direction of propagation is also in a rectilinear line, but only in the final class they learn about photons. And when I show them this photo made by Swiss University of Lausanne, they are very astonished, and they say, "Teacher, why you teach us many years something wrong?" And I explained then it's not possible to learn everything from the beginning. And how to break down this preconception, to speak about the first experiment of who proved the Einstein theory, the experiment made by two teams, but Arthur Eddington was the person who said it was very clearly that Einstein's theory is very good, because this the Newton's gravitational law is not enough to explain this deviation, because it was bigger. And what I show them after is the phenomenon of gravitation, the effect of gravitation lensing. And when they see such models here in these photos, I have very simple models from NASA course. And these photos are made by Rosa at home with something juice, but not juice, wine juice, yes, wine or grapes, with the torch, and here with the part of a glass. These models are to repeat the Einstein cross or the Einstein ring in the classroom with very simple objects. Of course, it's very good simulation, and also I put the simulation in front of them, and then they ask me many things, and why the researchers are so happy to have such tool, the astronomer, to have such tool in their researchers. Another preconception is what is between the sun and the earth. Usually they said vacuum. This vacuum is a very difficult notion to understand. Or nothing. How nothing, teacher? Nothing. This is nothing. But it's not nothing because...
Corina, 2 minutes left. 2 minutes left. Okay, sorry.
Thank you. Okay. And I have to tell them about the interstellar dust, about the wind, about the proof of this wind, the aurora, how this appear and where, about the lines of magnetic fields, and we can do in such a way we can repeat all physics, because there are many notions with this liaisons. There are many problems who are together, yes. And another preconception, does the sun move? No. All planets are moving around the sun, but the sun is not moving. Of course, that this we can also show them everything and to discuss and to show them the revolution movement and also the rotation movement. And I like this very much for small students. Sun's mass ratio between the sun's mass and solar system mass, and they said probably there are the same mass between the sun and the rest of the, or no, the sun has a smaller mass. But when I told them this is like this, the ratio, they, oh no, it's impossible. And for small children, I put many hundreds of cubes of sugar and to take the sun from here. And they are very creative. And
Corina, we are almost out of time, so please wrap up in one sheet. Okay.
There are other, and but you understand my ideas about preconception and how to destroy them, to make very simple experiments to show them. Thank you.
Okay, thank you very much. So I'm very sorry that we have
no, it's okay.
Okay, so please wait the Q&A session later.
Yes,
okay,
I know.
Thank you very much for a very important presentation. Thank you very much. Okay, so we will move to the next and the last presentation of this session by Nicoletta, Lanciano, and Néstor Camino, presenting about the meet the skies of the world. Nicoletta, are you there? Okay.
Yes.
Okay, so please go ahead. The stage is for you.
Okay.
I can see your presentation clearly.
I will begin. This is the report of the Intercontinental-experimental course, which we have developed months ago, Meet the Skies of the World. Nicoletta and I live in Europe and Patagonia. We have developed our activities in the teaching of astronomy for more than 30 years at now. In Italy, the MCA Sky Pedagogy Research Group, and in Argentina, Plaza del Cielo Complex, have been offering teachers and educators many projects and activities related to training and teaching learning process that have the sky and the study of the multiple relationships of humans with the sky as a focus of research, as well as the teaching of astronomy as a professional research activity. Over the years, we have developed didactical methods based on direct experience, naked eye activities, cooperation and exchange of experiences, and we have proposed in the city or in nature residential training workshops in which many teachers and school educators of all levels and various disciplines from different countries and continents and countries of the world have participated. For everyone in the world, COVID pandemic appeared, and we have to suspend all meeting activities we have planned. So we wanted to go on, and we must adapt ourselves in something different about the historical proposal we have experienced because of the physical distancing. So we decided to react constructively and creatively, helping us to travel and meet under the skies of different countries of the world, asking how we could transform ourselves into a resource that seemed to be the exact opposite of our customary practice, which was based on in-person contact, on direct experience, on active and reasoning together. Well, we will do it virtually. For decades, our courses have been workshops in which the participants are involved on a personal level, experiencing and understanding the materials as it impacts themselves and individuals before it impacts them as teachers and educators. Now we decided to explore the virtual possibility of meeting in the best way. So, Nicoletta, your mic. Your microphone, Nicoletta.
The force, Meet the Sky of the World, was born, proposed by the Italian group and organized in collaboration with friends and colleagues from Argentina, Colombia, and Brazil. We open to participants from other countries in Europe and America. Two courses were developed, each one having 4 virtual meetings, 2 hours and a half, during a period of 2 months, in June, July, and August, September. One near the solstice of June, and the other near the equinox of September. Responsible of the course is a team with colleagues and friends. And this experiment was possible and had a great pedagogical coherence thanks to the multi-year collaboration between the 7 coordinators from different countries. And participants, more than 10 teachers from Italia, Brazil, Colombia, Argentina, and some Italian in USA and Sweden, some French in Germany, some Brazilian in Portugal, participated in the course. We don't wanted more than this because our work was very laboratory, very working together, so it was difficult to have more people. And we feeling differences in the sky because of our longitudes. For example, the moon culminating from one, just rising for others, and differences in the sky because of our latitudes. Winter for one, summer for other, for example. And to meet these differences in real time was very, very strong. Some key items of our proposal for this course. Our peculiar and essential activities of observation of the sky by naked eye. It means that also in a physical distancing course, we suggested to observe the moon and the sun between a meeting and another, but also to go to look to our windows if moon rises during the meeting time. Another important point is the high presence of cultural links. It means to pay attention and to suggest some exchange of different calendars and mythology about the period of the year. The attention to the etymology of the words. For example, equinox is equinox, night. But for example, in Greek from antiquity is emeria, is the same day. So the words, they have differences in different countries and languages. But also
Nicoletta, 2 minutes left. Sorry, 2 minutes left, Nicoletta.
Okay, to invite everyone to share and make the events available to all in the day and in the night. And to practice a multicultural Néstor? A multicultural opening in the teaching of disciplines also. How different it is to live in the south and in the north of the world, for example. To you.
We work in contrast to the standardization of a single exchange language imposed on everyone in the world and of unique methods of explanation based on text, etc. And so all the work during the 2 months of each course were developed in Latin languages, Italian, Spanish, and Portuguese. We all talk and comprehend what we could in the 3 languages. To close our presentation, some examples. We compare real naked eye observations about the moon. For instance, the movement of the moon in the local sky here in the north, in equator, and in the south. The movement of the moon relative to the sun in the local sky day by day, an instrument to measure the angular difference between sun and the moon in the same moment in Italia and in Argentina to compare positions, situations about phases of the moon, etc. And about the night sky, the use planispherium in the south, in the north, and in the equator, and to comprehend better what we see and what we live, we use the Earth parallel globe and the horizon, for instance, in the south, in the equator, and in Rome, for instance, in the north. So we have different locations, different skies we perceive, but we all live in the same Earth, and we are all the same, for instance. If the pandemic continues, we will do another course. It's okay.
Okay. So I'm very sorry. So the 10 minutes is very short for you, but Are you okay to finish? Okay, thank you very much.
It's okay.
I'm very sorry. Thank you very much for very interesting and impressive presentation. Thank you for all of 4 presentators in this session. So we now have the question and answer session. So we have many questions and comments on question and answer window and the chat window. So I can pick up some of them. Okay, so there are some questions to Italo. So
Yes.
okay. So please wait a minute. So one question is from Silun, saying that very interesting. Where I can find more information about your project, like questions you asked. So, okay.
Can you repeat? Can you repeat the question, because I didn't get it. Sorry.
The question is that I would like to find more information about your questions asked. Yes.
Okay. Yes. We asked. We have 4 instruments. The interest was was in the slides. We asked to indicate the extent of agreement to 7 sentences about the interest in astronomy. I like to observe the sky at night. I like the I don't remember well, but I think you have seen this in my presentation. I would like to use a telescope. I found astronomy interesting. I had a strong interest in learning things about the universe, and so on. This is the interest scale. What I did not mention is that we also made a confirmatory factor analysis to fit the model with the questions. So we had more questions, but we had to discard some of them. The identity was one question. I would like to be an astronomer. It was an easy question because we asked this question. We asked this sentence from also for children and for also all the students. So we make a very simple sentence. I would like to be an astronomer. It is very easy to understand. And utility value, I think, is the learning astronomy is useful for my future. While the conceptual test is from the was about seasons, moon phases, and eclipses, solar and lunar eclipses. The questions were in multiple choice format, and for instance, the questions on the seasons were the seasonal changes are due mainly to change in distance between the sun and the earth, to the earth that goes around itself, to the length of the journey of the day that changes, and to the changing inclination of the solar rays that arrive to the earth. So that were the questions. There were multiple choice. We made
Okay, so Italo, thank you very much. Okay, so the many people want to know for example, the questionnaire sheet. Okay, so anyway, so please reply later on the question and answer panel. Okay, so you have many other questions, so please write your answer later on the panel. Okay, so another question is that the question is for the last presentation. Okay, so Néstor and Nicoletta, so some people want to join your project. I'm from Indonesia, South Asia. Hope can join with your project. Okay, so this is the comment and question. Okay, so maybe Indonesia is not the Latin language country, but is it okay to join your project?
Yes, of course. I'll send him our email to get in touch in the future. Thank you.
Yes, so I'm in Japan, so I'm also very interested in your project because the sky is for all people, so we can share the difference of the perspective, and we can understand the Earth is planet like this. Okay. So thank you very much for answering. So okay, so there are many comments saying that interesting and impressive, and I like your presentation. So maybe you can see the chat and some of the comments and questions you already answered. And the last one I would like to pick up is also the question to okay, Italo. Okay, so a quick question.
We can, sir.
Okay.
I promise.
Does the conceptual knowledge test includes topics other than seasons, eclipse, and moon phases? For example, exoplanets and black hole. Okay, so this is a question.
Yeah. I was typing the answer in the Q&A.
Okay.
But I can answer very briefly. Yes. For in our research study, no, because the topics that the children are taught in schools are limited to this kind of to very simple familiar phenomena. We are trying to extend it to a high school and also include some questions in the interest scale about the universe, exoplanets, and so on, because they do not do at least in some grade they do very small content about this more advanced topics. But I'm sure that would be very interesting to find out with the astrophysicists, for instance, if this is changed.
Okay, thank you very much. And Carla and Corina, so I'm sorry, I cannot convey any questions to you, but you can see many comments and questions on the chat and Q&A. So please look at later and reply. Please reply later. Okay, so thank you very much. The time is up. This session is ended. So thank you very much for all the presentators and all the participants. Thank you very much. Okay, so yeah, thank you very much. Beatrice.
I'm here.